Which of the following pairs of elements will form the least polar bond? Okay, so we're talking about least polarity. Remember, if you have a polar bond, polar means that there is some type of pull. There is some type of selfishness or greediness that one of the atoms have, and it pulls the electrons closer to that atom. Now we have a multiple choice here, right? Which one is going to have the least polar bond? Oxygen and fluorine, hydrogen and fluorine, hydrogen and hydrogen, and carbon and oxygen. Now, if we have the least polar bond, that means that we would have the least pull, which means that the atoms in the shared bond, and we could just write that out, right? We have O bound with F, we have H bound with F, and it doesn't really matter whether it's a single bond or a double bond to answer this question. I'm just going to make them all single bonds. H and H, and then C and O. Now, when we strip these bonds away, remember that there's always just electrons right smack down in the middle. If there is a polarity, that means that those electrons, I'll take this one for example, these electrons would be favored towards either the oxygen or either the fluorine. And the favoritism is the one that has the more electronegativity. The higher the electronegativity, the higher the pull for the atom. So it all just comes down to these values. So I'm just going to line them up, right? Oxygen has an electronegativity of 3.5. Fluorine has an electronegativity of 4.0. Hydrogen, and let's just do all these oxygens. So oxygen has 3.5. Okay, we'll do the hydrogens now. Hydrogen, 2.1 all around. Some textbooks have 2.1, but some have 2.2. But whatever they give you, if they give you a chart, you got to go by those numbers. And then fluorine is 4.0, and the carbon is 2.5. Okay. Now, the least polar bond would mean the least pull. Technically, I mean, if you want the least pull, that means that you want no pull, right? You want no selfishness, selfishness, right? No greediness. We want those electrons evenly shared, right? We don't want one atom to be pulling towards one side. And the only way that we're going to get that is the electronegativity difference between the two have to be as close or at least identical, right? If those electrons are evenly shared, the electronegativities have to be the same. So maybe I'll just say electronegativity. We'll put it over here. We'll say no pull means non-polar, right? Anytime that you see polar, you think of pull, that greediness. No pull means non-polar. Electronegativity difference is basically none. And difference just means that you're going to be subtracting the two values. They want to be as low as possible. And when you do your subtraction, when you do your electronegativity difference, just know that you always take the higher number and subtract it by the lower number, because the difference should always be a positive value. So like 3.5 to 4.0, if I subtract these two values, I get roughly 0.5 difference. And this is going to be much greater. But looky here, I have atoms that are exactly the same, 2.1 and 2.1. If you have atoms that are exactly the same in a bond, there's no way that the hydrogen on the left is like, I'm going to grab those. And the same thing for the hydrogen on the right, I'm going to grab them. They're the same atom. They have the same electronegativity. They have no pull. Those atoms are going to be right smack on down the middle. So I know that the electronegativity difference will be flat out 0. This is a pure nonpolar covalent bond. And I don't even have to go forward, but if we look down, this would have an electronegativity difference of 1. So my answer would be H and H. Which of the following would have the least polar bond? Least polar means most nonpolar, non-pull, or no pull. So it's got to be of the same atom. And there you go. What'd you think? Thank you so much for help. Thanks so much for helping me, right? We do it together. And thanks so much for helping out. And thanks so much for hanging out. So if you want more practice, head on over to our website, glazersguide.com. The link in the description below. If you click that, you will have tons more of these types of questions. So go and check it out. My brother and I, we've curated all of this stuff, just the two of us, to help you guys out in your class, all right? I hope you are doing well out there. And always remember that, the more practice you have, the more fun you're having, right? I think so. I hope you guys are having a great day, and I'll talk to you soon. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.